Hey everybody, today I want to talk about the role of gravity in the development and maintenance of our brain. So what does that mean? Well, if we don't have gravity, does that mean our brain falls apart? In a way it does, but also if we cannot perceive gravity effectively, our brain starts to fall apart. And it sounds like quite a radical statement, but I'm going to explain the whole story. But what that, in a practical perspective, one of the things we see is that if a joint isn't moving, or say you have several joints that aren't moving, that are really important. In other words, they have a lot of gravity sensors, and those joints stop moving. What happens to our brain? It starts to fall apart. We first started to realize this when we started sending astronauts into space. In space, there's no gravity, there's no load. Gravity is constantly pulling on our bodies, and we have sensors specific to perceiving that. So that constant load isn't there when you're in space. And what we found is that the astronauts, when they came back, they really had trouble walking. Even after a few days in space, their brains weren't working as effectively. They weren't getting that load of gravity, and so the brains stopped working so well. So why is that? Well, one of the things is really down to the development of our brain. When we went from being four-legged mammals to two-legged mammals, suddenly gravity was having a much greater effect on us. So we have sensors that are really sensing this load, and when you're on all fours, you're quite stable. You don't move that much, and the joints are kind of at an angle where they're not really gravity is kind of pulling them and shearing them, but not really compressing them. But as soon as we stand up, all of our vertebrae are suddenly getting a lot more compressive force from gravity. So those load sensors start giving a lot more information. Plus also, gravity is pulling us over. We have to be able to sense that and to be able to respond to gravity. So if we start to fall this way in relation to gravity, or because of gravity, our body has to sense that. So we have specific sense organs in our inner ear and in the muscles and joints of our body to be able to sense which way gravity is pulling us. So that meaning or that quality of information tells us that we need to respond to gravity, and we'll contract, and we have wiring that brings us back. Okay, so we have this constant kind of movement in relation to gravity. So these load sensors are constantly getting activated, okay, and they're constantly changing their inputs to the brain when we're standing upright. So what this is doing is giving a tremendous amount of stimulation to the brain. So when we go from being two-legged creatures to being four-legged creatures, when we first started doing that, we weren't really humans yet. We're still sort of apes, if you will, and we could hold ourselves up. But as soon as we're really spending a lot of time, and most of our time standing on 2 feet, we're getting this much more stimulation of gravity. And if we look at our brains compared to things that weren't on two legs, as soon as we start to stand up in relation to gravity, we're getting much more stimulation, and that extra stimulation is doing something in the brain. So previously the brain was relatively small, and when you start stimulating it more and more and more, you start to kind of grow it, okay? And it's kind of like a plant that sort of slowly unfurls. It has the potential to be a full-blown brain or a full-blown plant, but those little monkey brains didn't really get enough stimulation. So evolutionarily over time, we started to literally grow like a plant into the fullness of what our brain is now. And that push, if you will, that stimulation, that activation, came primarily from those load sensors, those sensors in our body that are telling our brain where gravity is. So these are very specific types of cells. And the greatest concentration of these is really in our joints, and in those joints is primarily in the neck. So the neck has a tremendous amount of sensors that are sensing movement, but also sensing this load. So as soon as we're upright and we're getting a lot of stimulation, that's evolutionarily creating the brain that we have, that we were born with, okay? And then as we develop from a baby to a child and an adult, we're becoming more and more upright. Babies are crawling around, but as soon as they start to sit upright, their brain lights up. They become much more human and alert and aware, and much more, like the person that they're going to be when they're an adult. So that activation of gravity is very, very important. So being able to perceive gravity effectively is not only important for the evolutionary development of our brain, but also the activation of our brain. So this is another kind of key component, is that neurological signals have a have a quality to them, so they have a meaning in the brain. They light up areas that tell us something about which way gravity is pulling on us, for instance. But that voltage is actually wired into all of those parts of our brain. So these load sensors are really, really highly activating different parts of our brain, really all the parts of our brain, to just kind of keep them functioning and active at a high level. So that makes us ready to work. It keeps the metabolism ready and alive and alert. Okay, so if that activation isn't there, then our awareness and our ability to function starts to drop away. So we see that with the astronauts again, if they are out in space, their brains start to function at a lower and lower and lower level. But at the same time, if we look at older people, when they lay down in bed, you're getting old, you're spending a lot of time in bed, you're not moving around as much. What happens? They start to have a more rapid decline of their brain function. So it's really getting up, moving around, and activating our brains, activating our bodies, that's activating our brains and getting us ready to function at a high degree. So if we're not moving and we're not having a consistent activation from gravity, it has quite a negative effect on our brain. So this activation of the brain isn't really, even though I say it's activating all the parts of the brain, it doesn't necessarily turn them all on, because that would make us feel crazy. What it does is it just gives it enough activation that it lights it up and it makes it ready to work. It's kind of like putting the street lights on in a darkened street. You have a completely dark neighborhood, but when you turn the lights on, suddenly you're ready to work and you're active and you can see the world, and now you're ready to go. Okay? Or it's like that cup of coffee. It just kind of wakes you up, but doesn't necessarily make your whole brain go crazy. It just kind of makes you more alert. So that's kind of the best way of looking at these load sensors, is not only it makes you more alert, but it gives your brain the activation it needs to keep all those cells healthy. So what does that mean? Why is that significant? Well, if we start to have less activation of load sensors, then our brain will start to decline. And it could be any part of our brain. So sometimes we're looking at the brain and we're saying, okay, well, this area is not working, this area is not working. And we're kind of trying to figure out all these different specific pathways. But a great deal of that time, it actually comes down to our body's ability to perceive load activation. So what does that look like? Well, anyone who's ever had a stiff neck or tension in your neck, a lot of these receptors are great concentration receptors. One of the greatest concentration receptors are really coming from our neck, because that's the bit that's moving the most. So our body has a tremendous amount of load sensors there. So imagine that if you had an accident and a whiplash, and suddenly your neck is really, really tight, you can't move your neck very well, but that means you're not also getting enough stimulation to your brain. If the neck isn't moving, yes, it's getting load, but it needs that kind of on-off function. So if you're not able to sense where gravity is and get enough stimulation, then it's going to start to have an effect. If you're laying flat on your back all the time and you're not moving, that's going to have an effect on our brain. So a lot of people are, come in complaining of just feeling a little bit brain foggy, or brain fog can be many things, but they just feel like they're just not quite active and alert and aware enough. What is that? Well, very often it could be just that those joints aren't moving, and the fact that the joints aren't moving means you're not getting enough stimulation and activation of those load sensors, and that decrease of load sensor activation over time is going to have a negative effect on our brains. So it's sort of a little bit of a different perspective. Usually I'm talking about the quality of it. Now we're kind of talking about the quantity of it, and that voltage and that push and that activation. If that's not there, we have joints that are stuck. It will decrease brain function. So one of the first things that I often look at when we're looking at someone's brain function is I just ask one of the very first questions is, how well is that person's nervous system, and how well are those joints capable of moving? How able are they to perceive gravity effectively? So that comes down to the load sensors. If a joint is stuck, one side might be loaded, but the other side doesn't get loaded. And that's going to have a negative effect on us. And if you have several joints all bending in different directions, eventually it's going to kind of take down the function of many parts of our brain. We're getting less and less and less of this voltage push that's activating our brain, and over time we become less and less and less aware. So getting those joints to function well is very, very important for many reasons. Today I'm just talking about the reason of being able to perceive gravity, being able to really tap into that source of energy, that source of stimulation that's going to just light up every part of the brain. So before we kind of nitpick which part of the brain isn't working very well, if these load sensors are not functioning well, then your brain's going to be really struggling. So switching that system on, getting that system working in a refined way is really, really going to be important for getting the whole of the brain functioning. So anyway, I go into more detail about this when I talk about adjusting to neutral. So if you want to hear more about what adjusting to neutral is and how we affect the load sensors, then tap into those videos. But I hope that gives a little bit of an insight into why gravity sense is so important, and when it fails, why that's so significant. So anyway, thanks for your patience. I know it's a bit of a long video. Thanks for watching. If you have any comments, drop them below. And if you have any questions, just let me know as well. So thanks again for watching.